we're going to talk about inverse functions. So first, we're going to be able to identify points in the inverse of a function when you're given points, or even a graph of a function, right? And then we're going to be able to find the inverse of a function given a function. We're going to be able to identify if functions are inverses by using composition of functions. And then we'll also be looking at a graph and telling if they're inverse functions just by seeing if they reflect the line y equals x. Okay, so first what we're going to talk about is looking at some points. Well, if AB is 1 point in an ordered pair relation, then BA is going to be an ordered pair in the inverse. And so what we're going to do is we're going to first look at the first example, but let's also remember what it means to be a function, right? To be a function, basically x's can't repeat, right? So each x, actually every x is paired with exactly 1y. So basically, x's can't repeat. Basically, that's just really what that means, okay? So these are some things to keep in mind. This is not a new concept for us, right? We learned this in Algebra 1. Okay, so let's look at example 1 for a second. It's asking if this original relation is a function. Well, let's look at the x's. 2, 4, 5, 0, negative 2. None of the x's repeat, so yes, which means they only belong to one y value. Now, if we were looking at the graph of these, which I just happen to have next to this, remember, this vertical line represents an x value. So as long as I'm looking and this x value only hits the graph once, there it hits only 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 once, then that means each one of these x values is only paired with one y value, because if I have more than 1 point here, that means that we have more than 1 point with the same x, which cannot happen if we're a function, okay? So now let's talk about what the inverse is, right? So to get the inverse, what we're going to do is we're going to change the jobs, right? Our B's become our A's, right? So we're just going to be switching these. So the first one would be 3, 2. So we'll go to 3 and we'll go to 2. The next one will be 1, 4, 1, 4. The next one would be 6, 5, 6, 5. The next one would be 7. We're just changing these, remember, you guys. So we're going to go 7, 0, 7, 0, and then 2, negative 2. 2, negative 2. Oh, that bad boy is going to be down there. Okay. Now, and we're going to try to see if this is a function. Well, we'll do the same exact thing that we did before. We're going to take that x value, right? And we're going to take it all the way through. It hits once on the blue, once on the blue, once on the blue, once on the blue, once on the blue. So the answer is yes on this one, right? But we could have also looked at the x's and seen that the x's did not repeat. Okay. So when we're asking what is the inverse of f, that's what this states, you guys. This means inverse of f. Inverse of f. So we want to do finding the inverse. So a function's inverse would look like that in function notation. So, well, let's look at the graph above for a second. Do you guys see if I draw the line y equals x, can you see the blue and the green all have partners that if I folded on the line y equals x, it would reflect that line, right? This one would land onto the, this one would land onto this one would land onto this one, etc., 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 right? So this is really important to see, because if I just had a graph of two functions and I wanted to see if they were inverses super quick, I would draw the line y equals x. Now remember, y equals mx plus b. So this means y equals, this is 1 over 1 x plus 0. Starts at 0 and goes up 1 over 1. It is a very important line because this point, when we have the line y equals x, the x's and y's are the same. So this would be like 7, 7, 8, 8, 9, 9, etc., etc., etc. Okay. So how do we find it if we were looking at points? Well, we can see on this one, we have this nice point right there. That is the point 0, -1. So our new point would be -1, 0. So that would go to this point right here. Actually, let's make that pink. Okay. And then let's look at another nice point. We're just going to pick one out. How about this point? This point is 1, 0. So that is going to go to 0, 1. Okay, and you can already see this graph kind of taking place, right? Taking shape. Okay, now we're going to take the point, this point right here. This point right here, which is -1, 0, is now going to map down to here. So you can see how these functions are kind of just like going on to itself. But you can see that when they cross, that's when the two values are going to be the same. And this is super messy, so I'm going to erase it because I don't really want it to be messy. So we're going to go here, here, here. And then we can pick ones that are a little bit further out, like this point right here is 2, 3. So now we're going to go, 2, 3. So we're going to go 3, 3 and then 2. So we're going to be here. Oops, pink. So you can see the first half graphing. So this part just mapped to that part, right? And now we'll map the rest of it by doing this point right here, which is -2, 3. We'll go to -2, 3. We're going to go to 3 and -2. And so this is just a little bit nicer way to look at that. But that's a little bit nicer. So sometimes it's kind of like messy when you're graphing inverses because they're going to hit at some points. If any points in the function, the original function, are on the y equals x axis, right? So how do we do it if we don't want to graph it and we just want to see the function? Well, the first thing we're going to do is we're going to change it out of function notation, and we're going to change the f of x to a y. That's going to be our first step. Our second step is going to be to exchange the x's and the y's. So I'm going to exchange the x's and the y's. And then we're going to solve for y, which means get y alone. And so we're going to be going, now I have x plus 1 is equal to y squared. We're going to take the square root, but when we take the square root, we do plus or minus. Remember we were talking about that? So this is y equals plus or minus the square root of x plus 1. And that's why you're getting the top and the bottom. Remember how we were talking about that a minute ago? And then you can change it back to function notation. So f inverse of x is plus or minus the square root of x plus 1. Now, the thing is that this is not a function, right? So really, we shouldn't even be putting this in function notation, so we can really just leave it like this, because it's not a function. Now, the thing is, if both the relation and its inverse are functions, then they're inverse functions, right? But in this case, they are not both functions, so they wouldn't be an inverse function. Okay, and we were just showing how we use the key points to graph f inverse. Okay, so let's look at this, and then we're asking, are these two functions and y? So remember that line, y equals x. So that's 1, 1, 2, 2, 3, 3. So if we draw this, and it takes literally no time to draw this line, you can see in this one, yes, they reflect this line. If I folded on that pink line, the blue would land on the red, right? On this one, though, if I draw this line, you would see folding the pink line would not land. So no, I said not, wrote not. Okay. No, they're not going to be inverses, right? Because they're not going to land on themselves. You could even just take like some key points, right? So this point would be 0, 3. Well, I should have 3, 0 on my graph, but 3, 0 is not on the blue. Do you guys see that? I hope so. Okay, so, all right. So now what we're going to do is we're going to be able to find out if they're functions without graphing them, if they're inverse functions without graphing them and without finding the inverse, right? So technically, could I take this, find the inverse, and see if it matched this? Yes, that is one way to do this. But I need you guys to understand how to check to see if they're inverses using composition of functions. Now, what I want you to think about is if I was talking about two inverse functions, we would say that B is in one and BA is in the other. So this would be in the function and this would be in the inverse, right? So if I compose these, and we're going to look at the function machine really quick. We don't have to draw the function machine. I just want you to see it. And remember, order matters, so we would do it both ways. We would compose F with F inverse, or F with G, right? And then G with F. And then we'll take this guy. So first we put the inverse first, then we put the inverse. First we put the inverse second, then we put the inverse first. So for the function F, I drop an A in, a B will come out, right? For the inverse function, when B goes in, A comes out. You can see that whatever went into this composition came back out, right? For the next composition, we first drop it into F of inverse, and the only thing we know is when B goes in, A comes out, right? And that's going into the F function. So when A goes in, a B comes out. So you can see that whatever goes into this composition will come out. Well, we're not going to want to put every single value into the composition. So we're just going to use X, and that X is just any value, right? So first we're going to do F of G of X, and then we're going to do G of F of X. Because remember, order matters with composition. So the first one we're going to do is we're going to take G of X, which is right here, and we're going to put it into F of X. So this is 2 times 4x minus 2 plus 4. So this is going to be 8x minus 4 plus 4. Sorry. And then you're going to come out with 8x. Well, if I put an x in, I better be getting an x out. Did I get an x out? No. So I don't even have to do the other ones. These are not inverses. Now, remember how I told you the other way to do it? Well, we could have taken the y equals 2x plus 4, switch the x and the y, and then solved for y, and we would have seen that this function is not the same as this function up there, right? So they're not the same. but we didn't have to because we did the composition. Okay, so let's do the next one. We're going to do f of g of x. We're putting an x in, so we better get an x out. So we put an x into g, and we get this coming out, and then we put that into here. So this is 5 times 1/5 x plus 3/5 minus 3. So when we distribute this, let's just go ahead and erase that. When we distribute this, we're going to get 1x, right? And then plus 3 minus 3, and so that equals x. So yes, when x went in, x came out. And then we do it the other way, g of f of x, and now we're going to put f of x in here. So we're going to go 1/5, and then we do 5x minus 3 plus 3/5. And so when we distribute this, we're going to get an x minus 3/5, and we still had plus 3/5. So guess what? We got an x. So the answer is yes, because when we put an x in to both compositions, we got an x coming out. So that means whatever went in came back out. So let's just talk one more second. If I told you that if I asked for f of f inverse of 3, you should be able to tell me if those are inverses, then whatever went in, came out. I don't even have to do it. If they're already telling me using the symbol and showing me inverses, I know that whatever goes in comes out. So if I was talking about g inverse of g to the -7, that is an ugly g, but -7 will come out because these are inverses, right? We're telling them that they're inverses. Okay, that's just like a little shortcut. All right, have a wonderful day, you guys.